Welcome to How to Become a Production SQL Database Administrator. My name is Raphael. In the previous video, we looked at what a bottleneck was, and we looked at some of the hardware resources. And I gave you a brief description of the CPU, the memory, the disk, and the network card or the network environment. And I gave you its kind of purpose, if you will. And I showed you that these are the four main areas that we want to monitor and keep an eye on. Now we're going to go into a little more in detail for each of these hardware resources and determine what are the counters that are associated with these physical hardware. So the first one I'm going to begin with is the CPU, and I'm going to show you some of the counters that we utilize in monitoring the CPU utilization. Now, before I even begin, I've highlighted this in red, and this is an important concept to understand. I have unfortunately experienced where working for a company where if they have any performance issues, they went out and bought a faster server, which cost thousands upon thousands of dollars, without understanding that maybe it wasn't the hardware that was causing the issues, but poorly designed databases and insufficient indexing. And these are the two areas that you can certainly rule out first before purchasing this. But the powers that be, they did not listen to me, and that's fine. And they ended up spending about $50,000 on the servers, and it was quite useless because after I tuned it within a week, it was superfluous. And everything worked great. So anyway, so always understand this. Before you make a decision of purchasing the CPU, more memory, and faster disks, rule out software issues first. And I'm going to show you that in a second. So I'm going to start slowly giving you, first talking about the CPU and the counters associated with it. And even within that, while there are many counters that you should monitor, we're just going to start slowly with a few, and then we'll continue with the memory and so on. So just remember this important concept. So start with obtaining a performance baseline. Now, as I mentioned, one of the most important things is to be able to have a baseline or a starting point where you can compare your future trends. The whole idea of SQL performance is to start building trends either on a weekly basis or a monthly basis, and then compare them each other and say, yes, last week or last month I had XYZ utilization of my CPU, and this month it's increased by 20%. And as time goes by, and 6 months later or a year later, and when you're doing comparisons, you can see the gradual increase of the saturation of the CPU, and it's a great tool to have for your upper management and say, hey, in the last year, we were worked our CPU, and we need a faster CPU. And then you can justify the upgrades. So this is a great way of monitoring it. So I'm going to show you now what are the few counters you do for baseline for CPU. A couple of things here just to mention hardware bottlenecks. As I mentioned, most hardware bottlenecks can be attributed to disk throughput, memory usage, processor usage, or network bandwidth. And these are the four areas that we've been talking about, just to reiterate. One problem can often mask another. And what I mean by that is you may think that the disk is causing a performance when it's actually your queries that needs to be fine-tuned. And so we'll talk about that also. You can also relieve bottlenecks by rescheduling resource-intense SQL activities so there's less load on the server. So just because it may not be necessarily the tuning of the queries, or it may not be the hardware itself, it just could be you're putting a lot of stress on the server itself at one time. So you're doing backups, you're doing indexing at the same time, and that would cause a tremendous amount of resource consumption. So basically you want to reschedule the indexing and backup procedures at a different time. So take a note of that. Obviously, one area you should check for performance is queries. As I've mentioned, indexing is important, and the utilization of SQL Profiler and the Database Tuning Advisor are great tools in determining what queries you can fine-tune. And we've gone over that before as to how to determine which queries are taking a long time to execute. So once you can do that, that will help in SQL performance. So some of the a little more definitions, CPU utilization. So a chronically high CPU utilization rate may indicate that the T-SQL queries need to be tuned, or that the CPU needs to be upgraded or replaced with a faster one, with a faster servers. Now, the cutoff point, if you will, is the CPU usage is greater than 80% consistently. This is the key word. You will certainly see consumption of CPU at 80% at times. The question is it doing it consistently for hours at a time or days at a time? If it just spikes or plateaus for a few minutes or a few hours and then it reduces down to 20%, then that is not a cause for changing the CPU. It's just that particular workload is causing stress. So take that in consideration. Same thing with memory. Insufficient memory either allocated or available to SQL Server degrades performance. SQL Server, note, is a hog for memory. It loves memory, and so if the more memory you can allocate to the server, certainly do that. Also, keep SQL Server separate from applications if possible. Keep SQL Server on its own and allocate the memory as much as you can to that server, providing you don't do 100%. Because obviously the operating system is going to need memory, and we don't want what's called page swapping. So if insufficient memory is not allocated to the SQL Server, then this is what happens. Data must be read from the disk rather than directly from the data cache, and this causes performance issues. Note that when data access is, if you have a choice for data to access from the disk or from the memory, just note that the memory is a lot faster than disk. So the more memory you have, the better it is. Disk input output. Transactional query can be tuned to reduce input output. Again, as we have said that many times, by employing indexes. And look at the concept of indexing and certainly deploy that so you can certainly reduce this. User connections. How many users are accessing the SQL server simultaneously? Obviously, if you have 2 or 3 or 5 or 10, that's possible, fine for connectivity. But if suddenly your business is growing larger and you got hundreds, if not 500, if not 1,000, then obviously this can be degrade performance. So you may want to look at the user connections also. Blocking issues. As I said, incorrectly designed application can cause locks and hamper concurrency. Now, I'm going to be talking about locking and blocking with separate videos, so I'll just leave that for here. But these are some of the reasons that it can cause bottlenecks and data resource consumption. So take a note of that. Let me just look at the time. So in this one, I'm going to talk about specifically the processor used and what counters to monitor. So we'll start with that. So again, I'm going to be repeating myself, and I'm doing that deliberately so it's ingrained in your head, because this is a very kind of complex area to understand, and the more redundancy you hear, it'll be easier to understand. So monitoring the processor, which is the CPU. High processor CPU utilization can be an indication that the processor needs to be upgraded to a faster or a better one. You need additional processors if your motherboard can handle it. And you have poorly designed applications. So all these three, as we've mentioned, contribute to the processor being utilized. And this is the whole idea of an investigation using a system monitor, is try to discover answers to why these are happening. By monitoring process activity over time, you can determine if your process is bottleneck and identify the activities placing excessive load on the processor. So take a note of that. So what are the monitors that we're going to start with monitoring? Well, again, as I said, there are many encounters and objects. You'll notice that when I open the performance monitor, this main subject is going to be the object, and within the object, you'll have multiple counters. So we're going to look at the processor object, and within that, as I said, there's many more, but the one we're looking for, and then we certainly look at, is percent processor time. This is value should be greater than 90%, consistently, less than 90%. That doesn't sound right. A consistent value of 90% or more indicates that processor bottleneck. I like to have a threshold of about 80-85%. I don't even want it to get to 90, and I want to be alert, and I'll show you that in coming videos. So monitor this for the processor in a multi-process system and total processor time. If you have multiple processors, we can measure that metric soon also. And then go to the object called system, and then we'll look at the counter called processor queue length. And this is the number of threads waiting for the processor time. So obviously, we as I said earlier, that if you have a processor that can then handle tremendous amount of queries and questions simultaneously, then that's a good processor, and it's an indication that the CPU can manage the workload. If it can't, then this is an issue. So we're going to look at these two. So in most cases, a processor bottleneck indicates that you either need to upgrade or a faster processor. In some cases, you can reduce the processor load by fine-tuning the application. So now you get a good idea of what the CPU is, its primary purpose, some of the key things to monitor, and what causes the bottlenecks. So let's go to now, let's go to the performance monitor and look at these two counters. So open here, I've got it right here, but you can open it up the way you wish. And let's look at, go to your performance monitor, and also you'll get the default right now. So right now, just delete it, and that's fine. We'll start from scratch. So we've got a blank canvas, if you will. Now we want to add the processor object. So go to your plus sign, and these are all the counters, and it automatically goes to the processor. So if you click down, you'll see now this is the object. These are the counters. The one we want to measure is processor time, percent processor time, and just highlight that. Remember, show description, and you can certainly read this. It's pretty complicated the way it's read. I don't like it, but I think I've given you an easier time way of understanding it. So just go add, and now that object has been added. The other thing we look at is go to system. So scroll down, SY, system. System, there it is. So there's the object, expand it. And the way we want to look, the one we want to look at is processor queue length, and go add, and then go OK. And now you have live time reading of both of these two counters. And remember, you can highlight it and then go to your highlighter here, and then you can visually see it, the consumption of the CPU processor. And if you want to know, obviously, how many processor queue lengths are waiting, remember, the number that we want to look for is less than 2. So you can see that the maximum is 0, so it's not really utilizing it. So that's a good thing. Now, obviously, there's no activity going on, so the processor is just humming along, taking care of the operating system and a few of the background processes that you have. So now let's stress it a little by, I'm going to open my SQL. And again, I'm going to run the same queries. Now, these queries that are being running, you have them also. They're basically just the people's table. So I've just got a couple of people table, people 2, people 3, and I'm just going to execute those in the background. So now watch what happens to the utilization of CPU. And as you suspect, it's going to start rising. Now let's just connect, I guess. And there we go. So now you can see that it started beginning to rise. And remember, the key thing is, while it rose from the average 20%, if you will, up to like 50%, it's not hovering anywhere near 85, 90%. So we're good. So at this point, this CPU can manage the workload that's been provided to it by this query. Now, obviously, as I said, we start adding more users, more applications, more activity going on, then this particular is going to spike. And what we're looking for now is a consistency of 80, 85%. This graph should be hovering over here for us to be concerned. So right now, I am not concerned. I don't need to change this utilization. I don't need to change the CPU. I don't need to upgrade the CPU. It's fine. If it hovered around here, that is a good indication that it needs to change. Now, having said that, that doesn't necessarily mean that I go out and run and quickly buy another server with a faster CPU and more expensive CPU and more CPUs themselves. It means I have to fine tune the reasoning why that's happening. And obviously, I'm going to be showing you that. And what I would do now is I would run a SQL profiler at the same time, and I started looking at the high running queries that are taking a long time, and see if I can fine tune those. See if we can find queries that are saying select all rather than just the specific tables like this. This is a select all. This is not a good query that we can fine tune. Look at the indexing. So there's a tremendous amount of activity that you have to do, before coming to a conclusion that you need to change your CPU. As I said, right now it's humming along, and that's fine. So I think I've given you an example. Now let's look at this one. Again, it's spiking, but you have to remember it's not average. The average is 7%. It has to be greater than 2 to be a cause. And you'll always see these spikes, but that's not what we're looking for. We want to look at plateaus. So this is fine also. So now I would collect this information. Now, obviously, I'm just doing it individually for demonstration purposes, just collecting basically the processor time. But I would collect the processor time, memory, and the few other encounters simultaneously, and then I would do those. You don't want to get too inundated with this because then it becomes very difficult to read. Right now, it's very easy because I only have 2 encounters. But I would suggest about 10 encounters or 12 encounters is fine, so you can read it very carefully. So I think I'm going to leave it here, and that gives you kind of an illustration now of how to monitor the CPU specifically, what to look for here, and what are the thresholds that would make your decisions. Hey, should we start fine-tuning, which you should always do first before you purchase the hardware. So I think I'm going to leave it here, and then the next one we'll talk about is the memory and look at specific counters that are related to counting. And this is basically now, I'm not involved SQL. Well, this I did, but I'm going to start looking at SQL encounters in the next videos and finding out what is causing this. So I'm going to leave it here, and we'll pick it up with memory in the next video. So my name is Raphael, and this is how to become a production SQL database administrator. See you in the next video.